Hello everyone. Today's video will teach you how to erect simple machines.
Objectives: at the end of this video, you can be able to erection of lathe machine, erection of drilling machine, erection of power hacksaw machine, testing the machines after erection. Let us briefly discuss on lathe machine. A lathe machine is an equipment that uses a tool that may be fed deeply into the workpiece and travel across it to remove unwanted material from spinning workpieces in the form of chips. One of the most adaptable and frequently used machines in the entire globe is the lathe. The mother of all machines is another name for the lathe because it enables a wide range of operations. The lathe machine has evolved into a general purpose machine tool used in manufacturing and repair work. The lathe machine's numerous components include bed. The lathe machine's bed serves as the framework for mounting all of the other components. The bed is supported by large box section columns and is made of cast iron or a nickel cast iron alloy. The guiding and sliding surfaces are present and its upper surface is either scraped or grounded. The bed is made of hefty metallic slides with forced ways or vesses along their length. Cross grids provide rigid support for it. Headstock. On left side of the bed, there is a headstock. Power transmission to the various components of the lathe is the headstock's primary duty. It correctly assigns and supports the main spindle inside the bearing. Additionally, it contains a gearbox system that is required, complete with levers for changing speeds. The following items are mounted on the headstock spindle: 3-jaws chuck, 4-jaws chuck. Tailstock. Tailstock is a movable casting located opposite to the headstock on the way of the bed. The basic function of the tailstock is to support the other end of the work when being machined. To hold a tool for performing operations like drilling, reaming, taping, etc. It consists of the dead centers, the adjusting screws, and the hand wheel. The body of the tailstock is adjustable on the base, which is mounted on the guideways of the bed and can be moved to and fro. Carriage. It is located between headstock and tailstock. It is used to hold and move the tool post along the bed either towards or away from the headstock. It slides on the guideways. It is also made of cast iron. It has 6 main parts: saddle, cross slide, compound rest, compound slide, tool post, apron. Saddle. It is a casting in the shape of a H that is fixed on the lathe ways and supports the cross slide that moves the tool post. Cross slide. During machining, a cross slide on the carriage enables the movement of a tool post at a right angle to the bed guideways. The feed screw moves the cross slide. Combination rest. A component that joins the cross slide and the compound slide is called compound rest. On top of the cross slide is attached the compound rest. It is manually controlled and does not get any power. Rotating the compound rest feed screw can be used to adjust the cut depth. The compound slide is securely locked with the base once it has been adjusted as necessary. Composite slide. The dovetail joint secures a compound slide to the compound rest. Angles or tapers that can't be cut by turning the headstock are cut using compound slides. Tool post. The compound slide stop is fastened to the carriage. It is used to rigidly hold the tools in the proper position. Apron. The carriage is equipped with an apron. It consists of the carriage's whole driving and controlling machinery. Feed devices that supply the carriage with automatic feed are used to secure the apron to the saddle. Chuck. It is a crucial piece of equipment that is utilized to hold and turn the workpiece. A chuck is capable of holding even the smallest bit of work. Faceplate. The faceplate can be job installed to carry out the turning operation and is fixed to the lathe spindle. Center. A center is a component of a lathe machine that supports lengthy tasks between the headstock and the tailstock during a lathe operation. A live center is a center that inserts into the headstock spindle and revolves alongside the workpiece. Feed shaft. It is constructed of high-quality alloy steel. It is positioned beneath the lead screw and extends the full length of the bed. There is a keyway where commands can be sent to move the carriage for the feed mechanism. The power feed gives the tool cross movement when it is attached. Lead screw. It is employed for cutting thread. The lead screw, which is located on the bed's bottom side and utilized to move the carriage automatically while thread cutting is there. It has Acme threads and is composed of high quality metal. Legs. Legs are utilized to support all of the machine's loads. They are anchored to the ground to stop vibration. Chip span. Chip span is placed lower side of the bed. The main function of it is to carry all chips removed by the workpiece. Hand wheel. This is the wheel that is operated by hand to move a crosslight, carriage, tailstock and the other parts that contains a hand wheel. Speed controller. The speed controller is located on the headstock, which controls the speed of the spindle. Bull gear. It is made from cast iron. It is used for slow and fast speeds by means of a bull gear backpin and is fixed by a key on the hollow spindle. Sleeve. Sleeve fits inside tailstock, which can be moved back and forth to fit or remove dead center. Erection of lathe machine. A lathe is a machining instrument mostly used for shaping wood or metal. It operates by having the workpiece revolve around a cutting tool that is fixed. The primary function is to remove the material's undesirable positions, leaving behind a neatly shaped workpiece. Select the space for proper functioning of machines such that machines normally must be conveniently accessible. Prepare the foundation plane as per the manufacturer instruction. As per the plan, foundation can be made. The following fundamental specifications for machine foundations must be met. The foundation must be strong enough to support the superimposed loads without failing through shear or crushing. The settlements should be within the permissible limits. As much as practical, the combined center of gravity of the machine and the foundation should be in the same vertical direction as the base plane center of gravity. To prevent resonance, the foundation soil system's natural frequency should either be too high or too low compared to the machine's operational frequency. It is recommended that the natural frequency be high for low-speed devices. A machine's rotational and reciprocating components should be perfectly balanced to reduce any imbalance forces or moments. Insert the holding down bolt before the foundation sets down. According to the weight of the machine, the depth of the foundation be made. Machine may be placed in position for leveling and aligning. To ensure that floors, ceilings and other surfaces are properly horizontal, leveling is also essential. Skipping the leveling procedure results in poor quality work, leading to crooked surfaces that are highly vulnerable to earthquake damage. Before setting the foundation, a foundation bolt inserted through the holding down hole in the basic of the machine. After setting the concrete, the machine is put on the foundation bolt in floor. Align the machine perfectly horizontal position using spirit level. The spirit level is applied to certain measuring areas both in longitudinal and cross direction. Insert wedges must be driven into the gap under the machine bed. After inserting wedge, check the level using spirit level. Grouting is carried out by pouring creamy mixture of almost pure cement. After setting grouting, the wedges may be removed. The machine base is then tightly screwed to the foundation bolts. After tightening the nuts, the correct position of the machine must once more be checked by means of the spirit level. Connect the power supply to the machine with the appropriate specification of circuit breakers. Finally, do the practical test and geometrical test. Practical test. The actual test jobs are prepared on the machine and the accuracy of the work created is then checked. Geometrical test. Verifying the sizes, forms, locations and relative alignment of components are all parts of geometric testing. They cover all operations such as planeness, alignment, axis intersections, parallelism and squareness of straight lines or planar surfaces. Safety precautions. When loading, slings should be protected from sharp edged by packing softwood. Before lifting, ensure the load is securely slung before taking the lift. When unloading, make sure that you have a firm foundation for your stack and make provision for the removal of slings without disturbing the stack. Let us discuss how to prepare a foundation plan for lathe machine. Objective: this shall help you to mark foundation layouts. Select the space for the erection of a center lathe machine. Mark points at a distance of 1 m maximum from the pillar or wall. Draw the baseline with the help of twine thread dipped in chalk powder or chalk solution. Construct the vertical baseline using 3-4-5 method as in a right angle triangle. Mark the total base area of the machine. Draw the central line of the base horizontally. Locate the position of the holes. Mount and level machine on anti-vibration pads. Objective: this shall help you to level the machine on anti-vibration pads. Lift the machine by crowbars and place wooden blocks under the machine at all the 4 corners. Select suitable anti-vibration pads depending upon the weight of the machine. Remove the leveling bolts from the metal casting. Mount anti-vibration pads under the machine. Fix leveling bolts to the metal casting through the foundation holes of the machine. Lift the machine slightly by crowbars and remove the wooden blocks from the machine. Level the machine both in longitudinal and transverse directions using a precision spirit level of accuracy 0.02 to 0.05 mm per meter. Position the carriage in the middle of the bed. Keep the spirit level on the rear slideway, that is, the slideway opposite the operator's side longitudinally at the position A. Keep the second spirit level transversely at the position C. Take the readings of both the spirit levels. Adjust the level of the bed till both the spirit levels show the same readings. Keep the spirit levels longitudinally and transversely at positions B and D. Adjust the level of the machine as required by screwing or unscrewing the leveling bolt. Finally, check the level of the machine with the spirit level. Lock the position of the machine by leveling lock nuts after completion of work. Recap.
In this video, we have learnt about the parts of a lathe machine and discussed how to prepare the foundation and erect the lathe machine. I hope after watching this video, you can be able to erect a lathe machine. Thank you for watching. Have a wonderful day.